Hello students. Okay, so far we've done a quick review of coordinate geometry, and we've shown you how to find the distance between any 2 points on a number plane, and also how to find the midpoint of a line joining those 2 points. Okay, now we're going to start looking at what are called linear functions, which is starting to get really into the heart of this particular unit. So once again, we'll start by just reviewing the terminology. So here we have a number plane with 2 lines called the axes. The 2 lines divide the number plane into 4 parts, which are called the quadrants, which are numbered 1, 2, 3, and 4 in an anti-clockwise direction starting in the upper right. Where the 2 lines intersect is called the origin. Horizontal line is called the x-axis. And I'll write an X along there just to show you that we actually do label it. The vertical line is called the y-axis, so we can label that with a Y. And I'm going to turn those off for now. And here's an example of what's called a linear graph. So that basically is going to end up being a rule, or the picture of a rule that links the 2 variables x and y. Where that graph crosses the y-axis, just there, is called the y-intercept, and where that graph crosses the x-axis, just there, is called the x-intercept. Okay, now this might be the single most important slide in the whole video series. We're going to show you how to represent what's called a linear function 4 different ways. First, verbally, with words, then as a table, then as a graph, and finally as an equation. So verbally, this actually describes the problem. A taxi driver charges $10 flagfall plus $5 per kilometer. Well, if we let distance be the distance that is driven and C be the total cost, then let's just fill in this table just based on what this problem actually tells us. So let's say that the taxi driver turns up but doesn't actually go anywhere. So you get into the cab and then you hop out again. Well, in theory at least, he can charge you $10. The flagfall basically means that's like the fixed amount for him just coming to your place or coming to you to pick you up. And then after that, you pay him an additional $5 per kilometer. So the cost, if he drives no kilometers at all, is $10. Now let's say he takes you a distance of 1 kilometer, where you pay the flagfall, which is like the fixed cost, plus $5 per kilometer. So that means that's going to cost you $15. If you go 2 kilometers, well, 2 times 5 is 10, plus 10 is 20. Now the nice thing about linear functions is there's a pattern to them. So in this case, that's going up by 5. That's going up by 5. So we can just continue the pattern. So often it's faster to just keep adding the constant term. So that's 25 and 30. Let's do a quick check. 4 times 5 is 20, plus 10 is 30. So another way to represent the rule, a linear function is just a rule. Another way to represent the rule is as a table. Now, if I want to draw the graph of that, that's like my x-coordinate, and that's like my y-coordinate. So the first row of the table represents the horizontal distance, and the second row of the table represents the vertical distance. I might draw this in red, I think. So first I'm going to plot some points first. So let me go ahead and get my point plotter. And I'm going to plot the point 0, 10. So that means starting at the origin, I run nowhere and I jump 10. And that gives me a point just there. The next point, the distance is 1 kilometer. So I go to 1 kilometer and the cost is $15. The next point, if I drive 2 kilometers, the taxi goes 2 kilometers, that's going to cost $20. 3 kilometers, it's going to cost $25. And finally, to go 4 kilometers, it's going to cost $30. Now notice how all of those points lie in a straight line, and that's why it's called a linear function, because the points lie in a straight line, and I can draw the graph of that just like so. In fact, it continues further because we don't have to just go 4 kilometers. We stopped the table there, but in theory we could go on for as large of a distance as we wanted to. So notice the graph has ended up being a straight line graph. Okay, finally, we need to get an equation. So basically the equation is going to be, how do I work out the cost? Whoops, let me undo that. And I have to go back to my writing tool. How do I work out the cost knowing the distance? And it turns out it's actually not too hard once you've got the table drawn to work out the equation. So basically, we look at the y-intercept. In other words, what does it cost if I go 0 kilometers? In the table, you find the value of 0 for the x-coordinate, or in this case, the value of d, and the c value or the y value will give you the y-intercept. So the fixed cost is $10. Now what I then have to work out is the running cost. Like for example, if I go 1 more kilometer, how much more is it going to cost me? Well, you can look at the table, look at the graph and sort of see that every time I go 1 unit to the right, the cost goes up by 5. A better way to do it, or another way to do it, I should say, is to look at this number here. Every time D goes up by 1, C goes up by 5. And the way we can represent that in an equation is we just multiply 5 multiplied by the distance. And there's the equation. Quick check. When D is 0, 5 times 0 is 0 plus 10. 0 distance costs me 10 kilometers. Let's try, say, 3. 5 times 3 is 15, plus 10 is 25. A 3 kilometer trip is going to cost me $25. So in fact, it does check. Now, so here's the secret to writing equations from a table. The constant term, which is the number, which we always write second, is just the fixed cost. In other words, if x is 0, or in this case distance is 0, it's the value of y or the value of c. So that's called the fixed cost. We have to add that on to the end. The running cost, or the variable cost, is every time x goes up by 1, in this case every time the distance goes up by 1 kilometer, what does the cost go up by? Well, every time you add 1 more kilometer to the distance, the cost goes up by 5, which is that number there, and that's going to be the coefficient on D. So that's just a very quick look at linear functions. We'll be doing a lot more practice and exercises on these very shortly.